Okay, so we're back for our second episode on machining the cylinder block, and today we're going to look at actually machining the bores for the piston valve liners and the main cylinders. So what I've got done before turning the camera on, we set the casting up in the mill. We've got one clamp at the back holding it down. That's going to be plenty for what we're doing. I've spaced it up off the bed of the machine with some parallels to give us about 6mm clearance underneath the boring bar, and I've also got the casting sitting dead square to the machine. Because we're going to be doing all these bores with numbers, because the holes have already been cast into the casting, we can't mark out centres to actually get a centre pot. So all we can do is find our datum points and then work out exactly where we're going to, all we can do is work out where the holes need to be with numbers and use the digital readouts to put our cutters in the right spot. So I'll show you. This is one of those things I hadn't seen until I was at the right workshop. So I'm just going to show you how I can get, that's assuming I can get it to focus where we want it to focus. There we go. Sorry about the camera work, I am a little new to this. So this is a technique for finding the edge or something. So what I've got, I've just got the drill chuck in the machine with a bit of tool steel poking at the bottom. And all we're going to do is start the machine, put a little bit of bearing glue on the bit of tool steel. You can't see it because of the very hard to do everything on the camera at the same time, but you'll see it when it comes down in the shot. So you can see the glue on the tool steel, and all we do is wind it into the job. The box of glue. And what will happen is when it touches, you'll see it rubs the glue off. Hopefully the camera picks that up. Let's zoom back out again. Sorry, I don't have a remote control for this camera, so we now know that the edge of this is in exactly the same spot as the edge of that. So I'll be back once I find some mics. Okay, so now that we've got our tool steel lined up with the edge of that, we can zero our digital readout. And we then know we have to move half our tool steel, which is 7.94. So if we move 3.97, and zero that one, on this plane, the centre of our spindle is now right on the edge of that bar. So what we do now, we repeat the process for this edge. Reset that one, and then remove our same 3.979. So now what we have done, let's swap this off. Try not to get this stuff on yourself because it gets everywhere. So we have now set the spindle, the readouts for the spindle, so it's zeroed right on this very back corner. So we can take our drill truck out here. I'll do that on the back. Okay, so off camera what I've done, I've moved our reference point from this point to the centre across here and that top edge. Because all our drawings are marked from this top edge, so that's going to be our reference point. And we know the centre distance between our two main bores there. So all we're going to do now is move our DROs, our table, to 60.32. And lock our table. And then our centres between our two cylinders is 47.625 millimetres. So if we divide that by 2, it gives us 23.8. So if we then move this way to 23.8, we'll lock our table. Sometimes that happens when you're locking tables. We're talking very small movements though. Okay, so now our tables are locked up. So this is a boring and facing head. All we're going to do is use it as a boring head. Today we're not going to use the facing function. So we'll wind that through. Make sure it's like a generator. And then we're just going to set our stop. And our stop just is there so that we don't hit the table. Go. So we'll just make sure of that. Loosen our stop off, pull it hard down into the table, and the ruler slides onto the board now, so we're right. So now we're just going to get our boring bar set for our first cut, which is always a little bit difficult on these jobs. Of course there are lumps and bumps. I think that's going to be all the way down the hole. So we'll lock that off, put it in low range, engage our feed first, low range, and away we go. Now, engage that loading. The machine does the rest for us. So that was our stop at work, stopping when we reach the bottom. So to reset, oh yeah, you can see, we loosen our lock, come in there, and each turn is 0.2 mil. So we've got a fair bit to take out, so we'll take a 4 mil. Then go again. And then it's just more and more of the same. Okay, so we bored all our holes out the same as you just seen. It's a rather boring job, so didn't want to record all of it. Excuse the pun. So our next step, while we're set up with our scales dialed in, we're going to drill all our holes for our cover mountings. We're going to do that using the DRO. What you can do, you can set up to our centre, tell our readout that we're starting from this point. We can then tell it we want 12 holes. We can tell it the PCD, and we can then tell it how far off the x-axis in degrees we want the first hole to be. So I'll set our PCD to 1 3/4, 12 holes, and we're 15 degrees off our x-axis for our first hole. So that's why I'm spinning the right way. So we just come down with our centre drill. And drill a 2.6mm hole, 1/4 inch deep. Just in case someone hasn't seen it, I'll show you what the DROs can do. All I have to do, once it's all set up, I won't show you the setup because each one's different, is push that button, and it tells me we're going to hole 2 of 12, and it tells me where I have to move to. So if I zero those scales and lock our table, like so, when we start our mill up and coming for our next hole, that's where we want to be. So from there we just repeat the process for all 24 holes on this side, and then we'll move on to our next part. Okay, so our cylinder block's now out of the mill. All our holes are drilled for this side. I haven't done that side yet because it means I have to set up. So the next stage, we're going to be putting our stainless steel liners in. This is something I've spoken to a few people about. They've never heard of this material before. It's actually used for re-sleeving brake cylinders in cars and trucks and tractors and that sort of stuff. It's stainless steel. It's about 1.5mm wall thickness. Sorry, the wall's about 1.5mm thick, and it tones out really, really well. And at the end of the day, it gives you a very nice bore. It also gives you a bore that won't rust, which if an engine's going to be sitting stage without being used for some time, it's a good thing. To fit them to the bores, all we use is 680 Loctite, which is that guy there. It works well. This is how I did work somewhere that was sleeving brake cylinders all the time, and this is all that holds our re-sleeve brake cylinder together. and they don't fail if you do a few things right. I don't know how well the camera picks it up, but you can see these grooves that have been machined onto the sleeve. They're only about 1/4 of a mil deep, and the way it was explained to me is that with the Loctite on there, if you don't put those on, sometimes they were getting failures, but if they put those grooves on, they described as being similar to an O-ring. So I'll try to get that in camera. So it just gives you a nice thick bit of Loctite just to help seal. If you're worried about them coming loose with that 680 Loctite, put one together and try and pull it apart. Basically, we did have to repair a few cylinders that have been done a long time in the past, and in order to get that Loctite out, we had to make the cylinder glow red to burn all the Loctite out before we could pull the sleeve out. So it's not coming out once it goes in. So the first stage is to give them a good clean. We should be using Loctite primer for this, but I've run out and don't have any, so that's just a bit of IPA cleaner. We've just got to get everything nice and clean. Ow. Sorry, I just walked into a mill. Trying to dodge a tripod while doing this sort of work isn't easy. We just give them a good clean. Down the boards as well. Nice clean rag. And knock any of the stuff off around the outside. Okay. So now we're ready to go. So what we need to do is need to coat both surfaces with the Loctite. So you're going to put a nice bead. So I'll try and do this inside the camera. Nice bead around the inside with both bores. Then again, just get a bit of a stick. So this is very hard to do, trying to watch what I'm doing and the camera at the same time. And then just spread the Loctite right around the ball. Don't just squeeze it around the outside and expect it to be all the way around. Of course, we are after a good seal as well as a good hold. We need to make sure we manually spread it all the way around. So coming from the other side, you know this Loctite is on the expensive side, but it's still cheaper to use a little bit extra, waste a little bit, and do it once as opposed to doing it 3 or 4 times. So that's a good coating all the way around. You don't have to worry about it going off while you're doing it like this. It won't go off until it's deprived of oxygen and you actually put them together. So that's both of those done. Now we do the same with the cylinders. So I probably wasn't getting that on the camera real well. Then just smear it all the way around the cylinders. This is a classic case of do what I say, not as I do. I should really be wearing gloves to be doing that sort of work. Right, so there's our sleeve all suited up. Now my fits here are a little bit on the loose side, so this is just going to drop straight in. Just give it a little twist as you go. Make sure at the bottom, there we go, and wipe off the excess. Now if I was being smart, I would have done that from the other side, so I didn't fill all my holes up with Loctite. So then we just repeat the process for the other side. Now one thing I will say is if your fits are a little bit tighter than mine were, I think I had a thou or two clearance. If you make them a bit tighter, what can happen is just the process of putting the sleeve in can set the Loctite off. So it's out of frame, but I've actually got my arbor press set up a few steps away. So if I felt the Loctite going off as I was pushing the sleeve in, I could race over to that just to finish the process. Yeah, make sure we're all the way through. Sit you up like that. And there we go. So I'm going to leave it there for this video. And next time round, we'll start marking out all the other myriad of holes. So we'll go through some basic marking out using the surface plate, the vernier height gauge and a few other bits and pieces. But if you like the video, please hit the like button. Any questions or comments, please don't hesitate to ask or leave them below. And yeah, we'll see you next time.